For years, the EV war has been a brutal race. Tesla versus the world. Legacy automakers, Chinese giants, secret startups, all throwing billions into batteries, motors, and hype. But no one, not Toyota, not BYD, not even Apple, saw this coming. Because Elon Musk just unveiled a completely new engine technology that doesn't just upgrade the EV, it redefines it. And the moment it hit the stage, the entire automotive industry froze. What Musk just revealed might be the final blow to the competition. A revolutionary drive system so advanced, so efficient, and so game-changing, it could wipe out every EV company that's been playing catch-up. And here's the kicker. It doesn't even rely on traditional lithium-ion batteries the same way anymore. This isn't just an engine. It's a technological death sentence for anyone who underestimated Tesla. In today's video, we're diving into the stunning details of this engine, how it works, what makes it decades ahead of its time, and why analysts are already calling it the EV war ender. Because what just happened may be remembered not as a new product launch, but as the day Tesla became untouchable. If you want to stay ahead of the EV revolution, smash that like button and subscribe now. Tesla launches a 2-ton car from 0 to 60 in under 2 seconds. No turbo, no gears, no engine roar, just silence and then shock waves. This wasn't just a performance number, it was a declaration of war. A war against combustion, complexity, and convention. And Elon Musk's new motor wasn't just a weapon, it was the endgame. The moment Tesla revealed the Plaid Model S, the crowd wasn't staring at a car. They were witnessing a turning point, the kind that splits history into before and after. Because hidden beneath the sleek, unassuming body was a powertrain no one else in the world had built, let alone mastered. Inside, spinning faster than any production EV motor before it, was a rotor doing over 20,000 revolutions per minute, a speed that would tear most motors apart from the inside. The centrifugal force alone was enough to split metal. Yet here it was, silent, stable, and deadly efficient. Why? Because Tesla cracked the code no one else could. While legacy automakers were obsessing over software and badges, Musk's team went deeper into the physics. They engineered the motor's rotor to spin so fast it literally threatened to explode. But instead of backing off, they wrapped it in carbon fiber. Not for aesthetics, for survival. See, most EV motors top out at around 16,000 RPM before things start shaking apart. Tesla's crossed 20,000. That's not an improvement. That's annihilation of the previous limit. And here's the kicker. They didn't just reach those speeds, they stayed there reliably. The secret, that carbon-sleeved rotor. It holds the copper core in an almost unnatural grip under immense tension. It prevents the rotor from ballooning outward due to centrifugal force. And that matters because the tighter that air gap between the spinning rotor and the surrounding stator, the stronger the magnetic field and the more efficient the motor. It's precision engineering at the atomic level. 1 micron off and the motor loses efficiency. 1 flaw in the sleeve and the rotor shatters. But Tesla didn't just make it work, they made it portable. At the Model S Plaid delivery event on June 10, 2021, Musk casually lifted the motor on stage by himself. It looked like a prop, but that small, almost cute package housed the most advanced EV motor on Earth. Light enough to lift, powerful enough to crush every other sedan on the market, and efficient enough to rewrite the laws of motion in mass-market electric cars. It wasn't just marketing hype. Tesla handed over the keys and Motor Trend got to test it. The numbers? Beyond expectations. The Plaid hit speeds a quarter faster than the previous Model S, clocking results that had engineers shaking their heads in disbelief. So how did they pull it off? Not just power, control. Without gears or shifting mechanisms, Tesla's new motor delivers pure torque from zero. No lag, no pause. The instant you touch the pedal, it's full send. The Plaid doesn't accelerate, it erupts. And it does it without noise, drama, or delay. A machine this heavy should feel like a tank. Instead, it dances like a sports bike. And unlike exotic engines that demand cooling breaks or maintenance rituals, Tesla's rotor keeps spinning quietly, efficiently, day after day. This isn't just about speed, it's about what that speed represents. The rotor's compact form means more space for battery, passengers, or even future applications. Its stability at ultra-high RPMs hints at users far beyond cars. Think aviation, robotics, even military. And the Anno Domini, the design choices aren't just radical, they're defiant. Instead of following legacy automakers into the endless race of adding more motors, more inverters, more weight, Tesla went inward. They optimized the core. They rethought what a motor could be, and in doing so, they made something that feels less like a drivetrain and more like a revelation. Look at the stats. The Plaid hit 60 in under 2 seconds, a quarter mile in 9.2. But it's how it gets there that matters. No transmission, no rev matching, no fake engine noise piped in through speakers. Just raw force transmitted instantly, silently, endlessly. This wasn't just the launch of a new car. It was the unveiling of a motor that broke through every previous boundary. Mechanical, thermal, magnetic. Tesla didn't just build a better EV. They built the blueprint for what every performance vehicle of the next decade will try to become. And it started with a carbon-wrapped rotor spinning faster than most people thought possible. Now let's talk about performance and efficiency benefits. The numbers sound impossible. 1,020 horsepower and 1,500 pound-feet of torque packed into a 4-door sedan you can drive to the grocery store. But that's not the full story, because what Tesla did with the Plaid Model S wasn't just break records. They broke the rules of performance and efficiency and rewrote the blueprint for every EV to come. Most automakers chase one of two things: power or range. Tesla delivered both, and did it with less weight, fewer parts, and a fraction of the energy loss. The secret wasn't just in the software or the batteries, it was in the motor design. Those carbon-sleeved rotors, spinning at over 20,000 RPM, were just the beginning. When you plant your foot on the Plaid's accelerator, you're not just unleashing brute force, you're activating a system engineered to extract maximum performance with minimal waste. 3 electric motors work in perfect unison to deliver that 1,020 horsepower punch. And what's astonishing isn't just the raw speed, it's the consistency. Whether you're at full charge or near empty, in hot conditions or cold, the car delivers unrelenting torque with almost no energy fade. No gears, no turbo lag, no delay. It doesn't overheat. It doesn't need a cool-down lap, and it doesn't drain your battery like a performance gas engine drains its tank. Tesla's motor design provides not only unprecedented torque and power, but also better thermal management, greater durability, and higher efficiency, especially under extreme load. And Tesla wasn't done. In March 2023, they revealed the next generation of their motor technology. And this is where things get really wild. They eliminated rare earth metals entirely. Not reduced, eliminated. That's a direct blow to the global supply chain that traditional EVs still rely on. It also means less geopolitical risk, less mining, and lower long-term costs. They also slash their use of silicon carbide, a key but expensive component in inverters, by 75%, cutting costs without sacrificing performance. In fact, the cost to manufacture one of these next-gen units? Around $1,000. That's not a typo. For a motor that can launch a car faster than a Bugatti Chiron, hit 200 miles per hour, and drive over 300 miles on a single charge, Tesla's now building it for less than a high-end laptop. These aren't just fast cars. These are scalable machines, machines that can be built by the hundreds of thousands and sold profitably. That's what sets Tesla apart. It's not just speed, it's sustainable speed at industrial scale. Let's talk numbers. 0 to 60 in 1.98 seconds, a quarter mile in 9.25 seconds, and it keeps pulling all the way to 200 miles per hour, all while carrying 4 people and a full-size trunk. That's not just supercar territory, it's world record territory. And Tesla didn't build it for bragging rights, they built it for mass production. Even with 21-inch wheels, the Plaid Model S delivers an EPA-rated range of 348 miles, with real-world highway range hovering around 300 miles. And despite the high speeds and triple motor output, it averages around 101 miles per gallon equivalent, numbers no internal combustion performance car could dream of touching. But performance alone doesn't win the EV war. Efficiency does. Tesla's motor architecture allows for remarkable energy control. No oversized cooling systems, no bulky thermal management. Everything is compact, refined, and integrated. That means lower drag, lower energy draw, and less complexity. And complexity is the enemy of scale. Because when you're building 500,000 cars per year, every bolt matters. Thanks for watching this video. Please subscribe to this channel.